while on one plot. I've just done so much with this one plot you would not believe. This is what it looks like. And the reason that I've sort of decided to kind of take you through one plot, basically, is because what I've sort of experienced is that you can make, it's quite easy, and there's really good examples to make like a demo plot, so to get started, and I'll show you those in just a couple of seconds. It's really easy to get started with Matplotlib, but it's very, very, very powerful, and therefore also ridiculously hard to kind of figure out, like from some of the help documentation. And I wanted to kind of show you and have you have this one sort of Jupyter notebook that you could potentially refer back to that might be helpful. And I'll answer any questions as you're going along. The first thing to ask you to do is, if you can't see this Viz tutorial in your Jupyter hub, which is, the address is hub.neurohackademy.org. The way that you get to see this is that you have to, I only gave it to Ariel about half an hour ago, and so you just have to click File, Hub Control Points. You need to just stop your server and then start it again. So I'll stop it, and this will take a minute or so, and then you'll start again, and then it should arrive. And that's actually, it's kind of really cool, and it's because every time the server restarts, it goes to all of the Git repositories and it looks for everything that's new, and so it will pull it all in. So you should hopefully get to this stage, and then you'll see it sort of spin up again. The GitHub repository, the URL is KirstieJ, which is my GitHub username, and then NH19 visualization. Inside of the Jupyter Hub has everything that you need. And there's a little readme here. And so just to start, I'm going to tell you about these Matplotlib and Seaborn galleries. When I found out about these, which was probably, sort of 5 or 6 years ago now, I couldn't believe that there was all of these examples that I could literally just copy and paste, and I could make that image all by myself. So if I open up the Matplotlib gallery, if I sort of just do a quick scroll, you can see all these different types of plots. I'm going to pick, I don't know, this one looks pretty wild. So this is interpolation for ImShow MatShow. It's kind of cool if you've got, actually you'll use ImShow if you ever have like a brain image and you want to show a picture of it. And the way that you can run it is literally just select all of that. I'm going to do Control-C, which is copy. And you go back to my Jupyter lab, open up a little notebook, paste in there, and run. The way I ran that was I did Shift or Control and Enter. Pay attention next time. And it's going to make me a figure with 18 axes. I'm going to tell you about what those are in a second. It's taking a little while. Oh, I know. So because we're in a notebook, we need to do Matplotlib in line. And we can run this, and boom, there's our figure. And if we go to the Seaborn galleries, it's the same thing. And maybe we really like these plots, these little plots. These look pretty cool. So again, you can literally just copy and new cell, paste. There's all my demo, and I can run it. And it's obsessed about type layout, but let's not worry about that. It's just a warning. We've got our nice stuff. And just to be super, super clear, I don't expect you to now know what all of this is doing, but I think that instead of teaching Matplotlib from like a first principles and building up, which is just like it's so overwhelming, it would be so difficult to do. I think it's really the best sort of plan to take an example plot that you like the look of and then adapt it for your use case. So that, I say in the, we go back to my README file, I say here that if you take absolutely nothing else from the session, so if you get lost within the first like 5 seconds of me pulling up my own notebook, all you need to know is that like there are all of these examples, and I strongly recommend that you just take the whole example and fiddle with it and play with it until you see the plot that it's plotting what you want to do. These instructions are for installing, but you don't have to do it. We only have an hour, and so don't worry about that. That's for kind of if you're working on your own machine at home. And I'm super happy to talk more about that. And then we'll go on this step-by-step tutorial now. So, let's close this untitled bit. We'll go to this tutorial. And I've made, so I've made a Jupyter notebook which is called Database Scatter. And that basically has the answers in it. And then I've made this Database Scatter live code where I've taken out all the plotting code cells. So this is the answers, and so if you want to play along by watching in that one, you should open it. I am going to open up my live code one, and then I'm going to sneakily have my answers in the background so that I can check them. So let's just get rid of this guy. So this is the live code one. And Michael and I published a paper called Neuroscientific Insights into the Development of Analogical Reasoning in 2017. And you can get the code and the data to recreate the figures from this GitHub URL. And this is figure 2. And I've already sort of said this, but I'm going to just really reiterate it again. Take what you need from this tutorial and just like leave all the bits that you don't follow or you don't care about. So it gets super pedantic towards the end as we kind of like twiddle the different figures to make them look really pretty. You just like, you bug out whenever you need to bug out. Like I get very excited about being able to place things in exactly the right spots. You do not need to be like me. Okay. So the first style is we're just importing some modules, and we're importing some of the things that we need, so we can just run that cell. There we go. And the task was a visual analogy task, where we asked 6 to 18-year-olds to line an MRI scanner. And there were 2 types of questions. So there's sort of the analogy questions asked, let's scroll this up a little bit, asked kids to say, which picture along the bottom makes the same relationship as the 2 pictures at the top. So dress lives in a wardrobe and milk lives in the fridge. So the correct answer is fridge. There is for these ones, there is a semantic law, which is that milk and cow are kind of, they're like semantically related, but they don't fulfill the analogy. There's a perceptual law, which means that the milk carton and this clock look kind of similar. And then there's an unrelated law, which is like, just shouldn't have anything to do with anything. And then there's a slightly easier question, which is which of the pictures along the bottom goes best with the picture at the top. And here the correct choice is pen, because these are semantically related. There's a perceptual law, because these 2 things look kind of similar. And then there's 2 unrelated laws. There's 2 unrelated kind of outcomes. So those are the answers. I've just written those down for future reference. And there's sort of 3 hypotheses. One is that as you get older, you'll be more accurate, and that your accuracy will be higher for the easy question than for the harder one. The other is that your reaction time will decrease as you get older. You'll get faster as you get older, but you will always be slower for the harder question. There's more to process. And then there's a hypothesis as well that there will be more semantic errors than perceptual errors, and more perceptual errors than distractor errors. So that's sort of building on previous literature. That's what we think is going to happen. But the number of errors will all be going down because the accuracy is going up. That's what we think is going to happen. And this, with great power comes great responsibility paragraph, is just to let you, just to sort of remind you that visualizations are really, really powerful. They can tell you so much, but they can also mislead you in very exciting ways. And so those hypotheses, you can only confirm those hypotheses by doing statistical tests. But the visualization will give you like a feeling for whether those tests make sense. So be careful, be responsible. The data is stored in the GitHub repository in this particular file, and I've made a copy of it, so you should all have inside of the data folder. So this tutorial data, you should have this behavioral data folder, file, CSV file. And these are the various sort of important columns. The relations, the semantic task has just one relation to think about, and the analogy task has two relations to think about, so that's why these are R1 and R2. Percentage accuracy, mean reaction time, and then the semantic perceptual, and we used to call them distractors, and then in the paper we changed them to unrelated. So that's the data, and this cell here is a bunch of pandas commands, it's only like 5 I think, that's going to read in the data. So if I'm going to run this cell here, we can look at the first 5 rows of the data, so we've got like some information about the subject IDs, we can tell which one's a male, which one's a female. It's an age scan. We can see various other sort of measures, and we scroll over to the right, the percentage, perceptual, percentage, semantic errors. There's lots of columns, so there's lots of different ways of like looking at this data. You can talk to me more about that in the future, but I've only kept certain ones that are really important, and so these are the ones now we've got a slightly smaller data frame. Okay. So look, I have an empty cell. This is because we're going to make a quick scatter plot. So watch this. PLT. Oh, I didn't show you that, sorry. Matplotlib highplot as PLT, and matplotlib inline. That's the matplotlib language that we've brought in. So we're going to say PLT dot scatter. We open up, and then df age scan. So that's the age that's going to go on the x-axis. And df, what did I say? Semantic accuracy. So R1 percent ac. And then if I run that cell, there you go. So that is literally as easy as it takes to make a plot. You can retire now. That is totally fine. You don't need to carry on. Well, you might sometimes want to see a different variable. So if I copy this, what I just typed here, and I paste it below, and then I change R1 to R2, so that's now our analogy question, that's the slightly harder one, and I run that cell, now I have 2 figures. So this one is the easy, that's the semantic, and this one is the analogy accuracy. So it says down here that'd be nice, but it'd probably be more useful if we put them on the same plot. And so if you're doing this in a notebook, you can take the first command and paste it, and you can take the second command and paste it below. And if we run that cell, we get the 2. So those are the 2 on top of each other. And I said, well, it's very clever. Matplotlib didn't make 2 different plots. It assumed that I would want these 2 plots on the same axis because they were in the same cell. Clever Matplotlib, well done. If I had put plot show, plt.show, in between them, I would have got the 2 that I wanted. So if I copy and paste these and put them below, and I enter in here plt.show, and I run that cell, then I get my 2 figures back again. So the scatter plot shows you how easy it is to plot the data. For example, you can check if you've got weird outliers or patterns of results. It's a really, really nice way to just kind of look and be like, yeah, everything's okay, I feel good. And I've said this before, I'll say it again, you can stop here if that's where you want to stop, that's totally okay. But if you want to have a bit more control, we're going to have to use a matplotlib figure and an axis. And I started writing a bunch of information about this, and then I was like, whoa, this is too much. Like, this is where if you click on this link and you go and look at the information for Matplotlib artists, you will descend into like the object-oriented kind of maze of power, and I just personally recommend that you don't. I think you can just understand that you get a figure, which is a figure, and there are axes within the figure. So they're like sort of areas that sit on top of your canvas. And I think that's all you really need to know. And let me show you the syntax for doing that. So fig ax equals PLT subplots. So this is going to run the default information for subplots, and it's going to return to you a figure, and the default is to just get one subplot, so just one axis. So I run that cell, and look, it just gives me like a plain old vanilla figure with an axis on it, no problem. So let's take that first part, and let's take our two scatter plots. And we're going to put those underneath, and we're going to add our plot show, so we are very explicitly telling Matplotlib to show us. Like I showed before, you don't need that at the very end, but it's kind of a nice way of like closing off that you've got to the end here. And I'm just going to change as well this PLT to ax. So now what I'm saying is, instead of saying just take your best guess at where I want this figure, I'm actually specifically saying make a scatter plot on this axis. So if I run this, boom, there you go. It looks exactly the same as it was before, but we've just been a little bit more explicit about where we want the figures to turn up. I put that in the wrong side. Take this away, put it down here, and then we're on this one. This is just our plain old, and this is our nice one. And I changed what to ax, and that's what I already said. Yeah, okay. Does anyone have any questions there? Can you give me like a general wave if you're sort of feeling okay? Okay, that's very good, thank you. That could have gone not so well. So, we wanted to test a hypothesis. We wanted to test if accuracy is increasing over time. So one of the things that we'll do is add a regression line. So we're going to actually predict accuracy based on age. I think it's going to increase at a decreasing rate. And I modeled it in the paper with a quadratic, and I don't need you to tell me that that is suboptimal. It's fine, it works okay. And so I use stats models to do this. Now, this cell here is, if you haven't used stat models, or if you haven't sort of come from like an R sort of space, the language R, sorry, my English accent gets very confusing with R. So this is the formula that's predicting accuracy on the semantic task. This is the formula that's predicting accuracy on the analogical reasoning task. And if I run this cell right here, I get some regression results. I can see that for the semantic task I'm predicting around about sort of, I've got an adjusted R square of 0.43. That's doing pretty good. And this line here, I get my predicted values. So for every data point, I give it like the point that the model is saying this is my best guess for accuracy. And I've just printed out those values here because they're just numbers, they're just accuracy guesses. And then I've done the same thing for R2, which is the analogical one, and I've got those values here. So we can plot it. Okay, so I don't want to type everything, so I'm going to go back up to this nice plot that we had. Let me copy this. And here's my empty space. And I'm going to copy this scatter plot and copy this scatter plot. So now I have two scatter plots for R1, two scatter plots for R2, so two for the easy, two for the hard. I'm going to change this one to get rid of this and just add in the predicted values. Let me go and see what I called those. So I called those predicted semantic and predicted so analogical. So predicted sem, and then here we'll put in predicted. So So this line is going to put the real data on. This line is going to put the predicted ones for the semantic task. This one's going to put the real data on, and this one's going to put the predicted on. So hopefully, yeah, look at that. There you go. So it looks okay. So we've got those predicted lines on there, but it's not how you would usually visualize them. You would usually put them on as a line rather than as individual data points, and you would probably make them the same color as the real data, right? And so the way to do that, and this is a bit of a strange thing, and I actually, when I was making this tutorial, I went down a rabbit hole, and then I just had to be like, just learn by rote that scatter doesn't do the thing that you want, plot does the thing that you want. So it's difficult, it's probably not impossible, because in Matplotlib there's so many options that probably nothing is impossible, but it's difficult to connect up the dots with scatter. So I'm going to use, instead of scatter, I'm going to say plot. And I personally find like Matplotlib plot to be a really unintuitive sort of command, because it's like, yes, I am plotting. Everything I'm doing is plotting. So it's one of the things that you would learn if I was teaching it from like the ground up, would be the first thing, and it's extremely powerful, but that makes it kind of difficult to use. So I'm telling you that there's a really nice way of using plot to draw a line. Let's run that. Oh, that is bad. So it's okay, because actually we've got the colors right, and those lines are probably there in the background, but we forgot to sort the data into ascending order. So when it connected up the data points, it connected them in the order that the people joined the study, and that means nothing, right? Like there is no point in joining up those two different people. So I left this piece of code in here. It's another piece of pandas that is going to take our predicted our predicted values for the semantic task, our predicted values for the analogical task. I'm going to put them into the data frame, and I'm going to sort the whole data frame by age scan. The data doesn't change, but I'm just going to like sort it so that they're in a nice order. So let's run that cell. And then, if I copy and paste this code from above, copy and paste, and run that. Oh, it's bad times. I know why. Everybody stand down. It's because, sorry, earlier when I was practicing, I got stuck on this for like 10 minutes. It's because I copied and pasted it, and so these are now the out of order ones. They're now being plotted in ascending order, but they're wrong because they're now not in the same order as the pandas one. Oh my goodness, that's really confusing. Let's just take the data from the data frame that we think should be there. That's why we put it in the data frame in the first place. Let's replace those two. And now let's run. Oh, that looks so much better. Well done, guys. We are great. But those lines are too thin. So we can put our code down here, and I can make the lines thicker by saying line width equals 5. Copy and paste that, and add it to my plot line again, and I can run that, and that looks really good. That looks really good. Okay, does anyone have any questions here? So the point that we're getting up to with this is that we've still got our figure, we've got our access, we've put some data on top of it, and now we're just starting to tweak it to make it look the way that we want to. Yeah?
What made the color of the lines change?
Yeah, it's very interesting. The next section is about adding a legend, but just the one after that is about the colours. So can I get to that? I think we'll have time. Can I get to that?
Yeah, so it was like orange and red, and now it's blue and orange.
Yeah, yeah. Okay, well, no, I don't need to. So it's the ordering of the default colours. So the first default colour is, well here, let me show you how we can figure that out. So I'm going to comment out these lines. So what this cell is now going to do is just run, it's going to make a figure and an axis, it's going to do the scatter plot just for the analogical reasoning, and the semantic task, and it's going to show it. So let's just run that. So the first colour is blue. The second color is orange. The third color is green. And the fourth color is red. So it's the order that we put the information in on. And the reason that these are just blue and orange is because, let me show you again with this. So if you just do the scatter, the first one is blue. If you add in the plot, they're both blue. This is our out of order one, don't worry about that. And that's because scatter and plot are different types of plots. So what Matplotlib is guessing for you, and there's a section further on where we're going to make it a bit more explicit the colours that we want, because this guessing is quite clever, but it's not going to be infallible. Is that it's going to say, okay, well, I'm going to rotate through your colours for the scatter plots, but I'm going to assume that using plt.plot is a different thing that you're thinking about. So I'm going to start from the cycling from 0 from the first one there. So if we just did the two scatter plots, we'd see a blue and an orange. And if I leave out the second line up here, so if I leave out plotting the semantic task and only leaving an analogical task, then that line is blue, it corresponds with orange. So that's a precursor for the section that's further down that's going to say that's what we can do. Does anyone else have any questions? Okay, cool. Let me, this is where I get a panic. Let's just check that if I run this cell down here again, yeah, okay, good. I still get my nice plot. So it's all looking good so far. The lines aren't labeled though, so this is not that helpful. I'm basically telling you, because I've looked at this data for 3 years of my PhD and beyond, that which one is which, and because I suppose we added them all in individually just then. If I take that code and put it in, then just at the very bottom, I say apps.legend. I add in some labels. Well, actually, let me get label label equals analogy. And I run this cell. Put in a legend. Now, in my README file, I have all of these instructions around installation. And I also have a requirements file, and those installation instructions, one of the commands is to install all of the packages that are listed in the requirements file. In here, I say that you should have Matplotlib version 3.1. But in JupyterLab, in the NeuroHackademy hub, we have print. Yeah, that doesn't work. It's really annoying actually. So you can import it as PLT, but I actually need to import matplotlib.version. And the version that we have installed on the Jupyter Hub is 2.0. And I just want to show you, because it makes me a little bit sad, that in the newest version, if I go to my one that I've run before, here's one I prepared earlier. So that is add a legend. When we add in the label for semantic and the label for analogy, and we don't add labels for the plots, the lines, it doesn't add them. So this is a difference between Matplotlib version 3.0 and Matplotlib version 3.1, that in the latest version, it's doing something quite clever, which is, well, I think it's clever, which is saying, if you haven't given something a label, we're not going to add it to the legend, okay? So if I go back to our JupyterLab, here we do have it in the legend. I think it looks kind of ugly. but installing new packages into the Jupyter Hub takes like half of our time. So we're not gonna do that for right now. Okay. Yeah.
So you can just create an empty label, right?
Oh yeah, good idea. Yeah. Very cool. Let's do that. Ooh, that's gonna look nice. Label equals. Brings me such joy. Thank you. That's so great. Oh, good. We're back with a beautiful plot. Yes.
Why I don't remember why do we need LT show? Like, we need to find it out.
No, in a notebook with the matplotlib inline, you don't need it. It works. Why do I like doing it? I like it because it's a bit more explicit that you want to show the plot. And I also think that you can sometimes end up, so if you have it with matplotlib inline, that magic that we put at the top, I think you would need them. You don't need the plot show. If you don't have that, and you're running these commands in a script rather than in a notebook, you can end up with all of these like hidden windows in the background where it's like making all these plots that you don't know that they're there. So there's something kind of nice about saying plot show, and it will like show you the plot. Yeah. So you don't need it. It's just sort of being explicit is better than being implicit. Any other questions that you can answer? Cool. Okay, so that's pretty cool. Matplotlib hasn't added the regression line to the legend. Well, it did. Then we fixed it, so that's amazing. And the legend positioning is very clever. Matplotlib has put it in the corner with the fewest dots. Well done. There's some documentation that shows you how to be explicit about where to put the legend, and the default value is best. And so that seems like a good default value. But if you want to be really explicit about where you put it, you can do that. So you just delete this cell, you don't need this cell. And let me just show you, if I copy and paste this code and put it down here, I can say lock equals, where do you want to put the legend? Children shout out.
Bottom middle.
Bottom middle, great. Yeah, so it'll be, let's see what center, bottom. No. Oh, see, it gives me the option. I knew it was going to do that, which is why I didn't bother actually looking at that. We want lower center. So location in this case, lower center. Boom, there it is. So we put it in a nice position. But we're going to keep it as best for now because I think it's pretty sensible default. Right, we already talked about colours a little bit, but we're going to talk about colours a bit more. So if I take this code and put it down here, let me just get rid of this lock cookie for best. And I move these lines around. So let's say that I take this and put it at the top. So now what I have as my first one is the predicted value for the analogical reasoning. Then I have the real data for the semantic, which is the easy task. Then I have the predicted value for the semantic, and then I have the real data for the analogical reasoning. Just change the order. It's the exact same lines, but just move the order around. And now if I run that, my colors are turned around. So we looked at this earlier. The first plot has gone in blue, and that's the analogical reasoning. That's the harder one, so these lines are lower, they're lower accuracies. And then the first scatter is the easier one, and that's up in the top. So this is an example where Matplotlib is trying to guess, and if we were being logical about the order that we were putting in the commands, then it would be guessing quite well. But there are better ways of sort of explicitly setting the colors. And the colors that this isn't wrong. Just ignore this, pretend like it's not there, move it down there. And take this code, pop it down here, and we'll say that we'll put the semantic in blue, so color equals blue, and we'll put this one as color equals blue as well, because they're both the easy tasks. And then we'll do color equals red. Oh wait, let me do this the other way around. That's going to be confusing. Red for the easy task, red for the easy task, blue for the hard. Color equals blue for the hard. And then yeah. So now we have red for semantic, blue for analogy, and my text down here says, cool, the colors are fixed, but wow, those aren't nice to look at. Those are some bright colors right there. So, I'm going to introduce now some color management with Seaborn. Seaborn is very high level. As I sort of showed from the gallery before, it can take your data and plot really, really fabulous visualizations very, very quickly. It does a lot of work for you in the background with Matplotlib. There's no free lunch, so if you then want to change some of the defaults and things like that in Seaborn, it can get really difficult to do, but you can, because it will always give you an access back, and you can play around with it in the same way that you would with Matplotlib. But one of the things it does is it has a really, really nice set of color palettes. So I am going to call the set one brewer color map. Let me just show you this color map. This is kind of fun. So these are qualitative, so different colors. This happens to just the name of it is called set one. And I've just told it to have 5 colors, and this is an example of those 5 colors. And so this line says, get a color list from Seaborn color palette. The name is set 1, and we're going to get 5 colors from it. So that's what that line is saying. And then I'm going to print the RGB values for each of the items in the color list. And that's just because I want you to see what's inside of that list. And then this is a cute little command called palplot, which is not your friend, it's a palette plot. And it's going to show you those colors in a nice kind of intuitive way. So we run that cell, and these are our RGB values, 1, 2, 3, 4, 5, and these are our colors that they correspond to, 1, 2, 3, 4, 5. And those colors are in a list, and we can index that list with the numbers 0, 1, 2, 3, 4. So now we have much nicer colors. Let's change the red and blue in our accuracy plot. So we'll go up here. This one has red and blue, but it's like, whoa, super ugly. I'm also going to, I'm just going to move the plot like back to the right order, because it was sort of stressing me out having them out of order. So instead of the color being red, we're going to have the color list 0, which is the first item in the color list. And for the semantic predicted value, it's also the same color, the first color in the list. And then, whoops, for the second one, it's color list 1. Color list 1. So it's going to be the first color for the easy task and the second color for the harder task. R2, line equals 5, label equals 5. Oh, color equals color list. Then told it what it was supposed to be. It was just like, I don't know what you need for this color list. So color equals color list. Go. See, much nicer. What questions does anyone have about that sort? Okay, we're all feeling good, like stepping through, it's like one freaking plot, and we're just really digging into it. Seaborn can do more, very exciting. And what Seaborn can do is it can set the context of the plot and the figure style. Let me just open up this link to the aesthetics tutorial. So I would say so let me just open up the gallery because I was sort of talking about it before. So there are all these gallery, like really quite sort of fancy plots that you can do in Seaborn. So, this is a pretty cool like cluster map that you can do. And again, it has all the code for you to do it. Here's some fun violin plots, for example. Even if you never actually use a seaborn plot from the gallery, the figure aesthetics are so lovely. And now that Matplotlib is in version 3, you don't need seaborn as much because they changed a lot of the default aesthetics when they moved from version 2 to version 3. And the version 2 used to be really ugly and now 3 is much nicer. But this part that I'm going to show you about set context and set style are really lovely. So there are these various different kind of, they are like aesthetics for the plot that you can choose. So the, here's another one. So we're going to check out the poster context with a dark grid background. So, here we go. Seaborn, set style, dark grid, and seaborn, set context, poster. Okay? I use those, like the single quotes and the double quotes, they don't make any difference. They're doing the same thing. They're marking a string. So we run that, and that's set now in our environment, that context and that style. So let's take this exact same code as before, copy, paste, and run it. And whoa, it doesn't look so good. So it's changed the style. It's kind of artistic, but not in a good way. But it was attractive, that's no good. How about the notebook context with a ticks background? So we're going to copy these two. I'm going to write this down here. So set context to notebook and set the style to ticks. We run that, and that sets it globally for everywhere. And then we grab our code, copy, paste, and run that. And okay, this is better. And you're actually back at the Matplotlib default now. I personally don't really like these like over-exaggerated ticks, but that's okay. Each to their own. It's where you get to control your own aesthetics. The settings have changed slightly since I wrote the original code in 2016, but I think the closest setting is notebooks with a font scale of 1.5 and the white style. So let's go grab these two again. So we're going to say it's the notebook with a font scale equals 1.5. So that's going to scale, it's in the name, it's going to scale the fonts by a factor of 1.5 and make them 1.5 times larger. And we're going to use the white style. So let's run that. Let's go code, copy, paste, run. And that's I think that looks pretty nice. Yes.
Does setting the style and context set it for just that plot, or for any other plot you make after? If you're making a bunch of plots with different styles or whatever, do you have to change it each time?
Yeah, so great question. So the question is, does it set, if you set the context and set the style, does it just set the context and style for that one plot, or does it set it for everything? And the answer is it sets it for everything until you go ahead and change it. There is a way of, there's a setting in the tutorial about temporarily setting the figure style. So if you want to have like a regular figure style that is like yours, so what I do for all of my notebooks is that I have this at the very top. So it's underneath all of my imports. I put that at the very top, and then everything I do has those aesthetics. But you can, so here for example it's saying with seaborn axis style dark grid, do a plot, and then add a subplot, but because it's outside of the with statement, it goes back to the default coloring. So that first plot here is using the dark grid, and the second plot goes back to just the defaults. So that's how you would do it if you wanted to just control one of the figures. But I think it does a really nice job of, if you find a style that you like the look of, you can just put it at the top of either your script or at the top of your notebook, and you'll have that style for everything. Thanks for asking that. Are there any other questions? I'm gonna, oh, I like having them de-spined, so let me just copy and paste, and I'm going to add a little thing down here that says SNS de-spine, de-spline. If we run that, what de-spine does is it gets rid of the top and the top and the right side. I just think that looks kind of neater. Right, I've got 10 minutes. I think we can do the axis labels, limits, and tick placement. So our plots don't have any axis labels. That is problematic. Like, these are not publication level. These are not even like going in and having a meeting with your collaborators level if you're not labeling your axes. So let's go ahead, as the smiley cat says, and label them. So we're going to, building up this plot, so we're going to copy and paste. And we'll put it in before the legend, and we'll say ax dot x label, set x label, age, and we'll set the y label to accuracy. Let's see what happens. Yeah. Oh, how nice. Look at these two. So we labeled our axes. So we just said for this axis, set the x label and set the y label. One of the really nice things to do is be able to set the min and max values for a figure. So Matplotlib is doing a really good job of guessing where we want our min and max values. So it's got like a little bit of white space here, it's left us a little bit of white space at the edge, you know, we've got some good space at the top. And so you quite probably don't need to set the min and max values. I feel like weirdly, deeply, passionately about setting the min and max values, and it's because in my postdoc I did one of the analyses that I did was I split the data into two sets, and then I ran everything separately for these two different data sets. And I wanted to be able to flip between the figures. So I wanted to be able to have like the figure of the data set. It was the discovery data set and then the validation data set. And I wanted to be able to like put it up on a screen and just flip between them and show that the lines looked really similar, show that the data points, although the data points moved around, the patterns were extremely similar. And the problem is that when values are being guessed, they're ever so slightly off when you have different sets of data. And so one of the things that I'm really interested in is trying to like actually explicitly set the min and max values. So what we can do is we can see what the values are that it's guessing by saying print ax get xlim, and get xlim is a command, and so we have to call it. We can do the same for get ylim. So this is print, so it's going from 5.3 to 19.6 and then 9.7 to 104 for the accuracies. And that looks really good. Like, it's really good. I'm going to show you this little function that I wrote because I think it does kind of a nice job. You can get the min and max from like the whole data set, for example. That's what I did in my postdoc. And then you can save these data min and data max values somewhere else. You can put them in a dictionary or something like that. And then you can go and call those every time. And my personal recommendation, I think it's really nice if you take the whole range of the data and then you pad by 5% on either side. I think that just makes it look really nice. So that's what this little function is doing. It's calculating the data range, and then it's giving you the pad percent. It's adding, subtracting for the minimum and adding 5% to the top. The 5% is the default here. So this, and we're going to say ax. So let's get the value. So let's say they're returned from get min max of, and we'll pick the value that has the largest range, which is this one. Oh, hang on, this is fun. This is y min y max and x min x max are age scans. Age scans on the x-axis. Percentage accuracy is on the y, and so if you print x min, x max, and then y max. And we can say, instead of get xlin, we can set, see that? Get, set xlin, x min, x max, and we can y min, and y max. I can run that. I didn't like it. Oh, because I didn't run the cell above. Run that. And then run this. And there you go. And it looks really similar, but it's now explicitly setting those values. And I just want to show you if I copy and paste this, and I set the pad percentage to 0. I set the pad percentage to 0. It looks stupid because it's like cutting off at the maximum value. So that's why that padding looks really nice. Then the tick placement. I've only got 5 minutes left, so what I'm going to do, if it's okay with you, is I'm going to flip to my one that already has everything filled in, and we'll just zoom through the last little parts. So inside this tutorial, inside data scatter, and then we're going to just scroll. It's all the same stuff, except our labels are pretty long. So let's get to where we were. Yeah. And we're just going to run all above selected cell. So you should get some plots popping up. This is like, it's auto scrolling because all of these things are here and go. So we've got some plots. This looks silly. So the tick placement, what I can do here is set X ticks, and I'm telling it, oh sorry, I'm dragging something. I just want it to have the ticks along the x-axis at those specific values. So it's super easy. I will say I've Googled for this every single time I've ever had to use it. So one of the reasons that I put it in here is because if you remember to go and look here and search for ticks, then that's a good recommendation. And then for the Y ticks, there's this very cool ticker locator params, which is kind of, again, if you go and read the help, it's like super, super intense. But what this does is it says, tell me where you think, oh great, matplotlib, I should put the ticks if I want there to be a maximum of 4 ticks. That's what this n-bins equals 4 on the y-axis is saying. So let's run this. And it's done, it's put them in a really nice place. Now, I had in my original code 6 bins, so let's put the 6 bins in here because we're going to make it look similar. And that's pretty good. What's kind of interesting is that it can't figure out, matplotlib can't figure out a nice way to put in 6 ticks. Like that would be weird sort of decimal values and it doesn't make sense. So it hasn't. It's just gone with a maximum of 6 and it said, here are 5 numbers. You're going to have to just look at that quickly, which I think looks great. And if I had time, I would go back and get rid of my labels for here. Now, the last thing that I'll show you in my last like 3 minutes is that actually Seaborn has a function called regplot, which puts the regression line on for you, so you don't have to do it separately in these 2 parts, this axis and plot part. and it puts in confidence intervals, and you can adjust those confidence intervals. It's got a lot more like stats knowledge in the back of it. And so what I have here is I've just replaced the plot and scatter for the easy task with red plot for our 1% act, red plot for our 2% act. I've got my x min, y min, y max, got my labels and despining. And if you leave the default on, you fit a straight line. Straight line doesn't make any sense. So we can tell it to set order equals 2, and that's now fitting a second order polynomial, which is a quadratic curve, and we can run that, and look at that, that's a really beautiful plot. This is advanced legending. Come to office hours if you want to know how to do advanced legending. What it does is a really nice like straight line instead of adding the dots in there. And your figure looks just like the published one. Congratulations. Very exciting. Now, that got like picky, right? That got like into all of these different sort of nitty-gritty parts. But if we take that code that we wrote above and literally only change the y variable that we're plotting, and we run this cell, so I've changed this to mean reaction time now instead of accuracy, and I run it, boom, we're done. We've got that second plot in the published figure without having to do anything else. Isn't that nice? So this I got very excited with my rockets and stars. And the third plot of the errors, there's actually 3 types of errors, so we have it 3 times over to change it ever so slightly, but it's still very, very similar. I then wrote a general function that takes in any of the variables that you want to plot, any lists of any of the variables, and that will now do accuracy, reaction time, and the reaction time for the errors. This is wrong. That's the wrong label. That should say percentage response. And then lastly, we've got 3 subplots. This is allowing you now, instead of having that one figure with one axis, you can have one figure with a list of axes. And here I've told it to do 3. I've told it to do 1 row with 3 columns. And it makes a figures directory if it doesn't already exist. I can do my accuracy plot, my reaction time plot, and my errors plot. Let's fix this here to and there you go. 1, 2, 3. We've made it. We can save the figure. And then this part is adding the panel labels. This is completely ridiculous, and you should definitely just do this in PowerPoint and Inkscape or wherever else you want to do it. What this function is doing is saying, take a piece of text and add in letters that go in order A, B, C, and put them in a particular position in all of these various different spaces, make them arrow, make them bold, put them in these places. We've done it. It's like a weird symbol where if I open it. No, it's just we made the figure. And this is slightly off, so this when you're plotting these in places, actually, you just like move them around manually, you just save the values. But you can at least move them around manually and then run your code over and over again. Okay, I've gone slightly over in time, sorry about that. Please come and chat with me if you have any other questions, and I hope that sort of was at least maybe a little bit exciting up to the point that you were like, don't this